Hey everybody, Dave here. Today I'm going to show you the solution I made in Power Automate Desktop to solve Minesweeper. This took me a long time to make, and there's a whole bunch involved with it. In the beginning of this video, I'm going to do the same thing I normally do. I'll give you a demo of what I've made, and in this case, I've actually recorded the demo several times, so it's going to be at the beginning and at the end, and they're actually two different demos. So if you're interested in seeing this thing run through a few times, watch the beginning of this, get to the technical part, and then if you'd like, you can skip all the way close to the end, use the chapters feature, and there should be one called demo or something like that, or final demo or whatever. And then you can skip to that and you can watch it run a few more times. In that later one, I let it run through all three difficulty settings, beginner, intermediate, and expert inside of this Minesweeper app. Let's go ahead and demo this at the beginning, just so we can see what the solution does. Any of you who are here just to see this thing run a little bit, this is the part you want to see. I'm going to click yes. Power Automate is waiting for me to answer this. I'm going to click yes, and it's going to start running. What I plan to do is let this thing run through a few times to let it solve the beginner level, which is what you see on the screen here. This is an 8x8 Minesweeper board. If you're not familiar with Minesweeper rules, I will talk about that later in the video, but you'd have to watch pretty much the whole technical part to get that. So I'm going to say a few things now. The numbers you see on the game board represent how many mines are nearby. There are a maximum of 8 tiles near any one number. So if you see a 1, there are 8 tiles around it, and there is one mine in one of those 8 tiles. In this case, the automation is designed with a few simple rules. There are more rules that you could build into an automation, but I don't know how to build that into a Power Automate flow. It does some of the most basic things, and you'll see it's just going to loop over all the different numbers. It uses SQL Server to track some of the information. It uses image recognition by using various actions in Power Automate Desktop to identify the types of all of the tiles. And I'm going to go ahead and click no, that we don't want to keep playing here because it did solve the beginner level. I'm going to change it to intermediate, and then I'm going to hit run again, or it's going to ask me if I want to play. So I'm going to click yes. And so now it's going to solve the intermediate level. In this initial demo, I probably won't do the expert because it takes quite a while for that to run. And so if you want to see it do the expert level, skip to the end after you see this part, and you'll see it do the beginner, intermediate, and expert again. Something I'll talk about here is that, like I mentioned, this is purely image recognition. Each of these individual tiles are not spied or selected or captured or whatever words you want to use. This is using almost purely image recognition. There's only one UI element in this flow at all, and the rest of it is all images. The way it's working is I use the X and Y coordinates to narrow down where it's looking on the screen to determine, is this a 1, is it a 2, is it a 3, is it a blank, is it new, is it a flag, etc. And then it keeps track of all that. Then it loops through all of the numbers and looks at nearby tiles to determine, based upon certain rules that Minesweeper has, can I click on these tiles? So can I left click on it, which will expose the number underneath, which might be a mine or whatever, or it will right click on a tile so that it creates those flags that you're seeing. Everywhere that you see a flag is a mine, and everywhere that you see a number or a blank or whatever, that means there wasn't a mine underneath that. And we use those numbers to help us identify what we can click on and what we can't. Feel free at this point to skip to wherever you'd like in the video, but this one's going to be a little bit different. Normally, I like to show every single step that I do, right? I'm not going to do that here. However, you will see every single action that I've built. You'll see every subflow and every flow that I've built for this. You might not, however, see every single input parameter that I've filled out or output or whatever, because I'm not going in great detail. I do spend about an hour and a half, I think, explaining this, which I've already recorded that part, so I know about how long it is, but I haven't edited the video yet. So just recognize that this is different from other videos where you may not be able to follow every single step. However, if you watch this thing, all hour and a half of it, and you're like, Dave, I'd like to build this thing too. I want to see every single step that you made. Just tell me and I will go record that. It might be 4 hours long, but if even one person wants to see it, I'll go ahead and record it. But I'm not going to do it unless there's at least one person who wants that. And so this will have to suffice for showing you this kind of steps I implemented. So while this is running, let me mention a couple things in case you don't watch the whole video. A couple things I learned. The if image action has an input called x2. That thing does not work properly. And any number you put there, you need to add 1 to it. So you're giving it a pixel count, basically. You need to add 1 pixel to that for that x2 input. Another thing is that several of the actions that related to images have an occurrence input that is a static input. You can choose 1, 2, 3, 4. Basically, the fourth or fifth, etc. instance of a certain image. And you can have it click on that or just move the cursor to it. It's very useful. The problem is that I'm not going to know when I design this thing, whether I want to click on the second or third or fourth image. I need that. Personally, I would want that in order to have the flexibility I need in order to automate anything. So that needs to be a variable input, that occurrence input. And then another thing a big thing that I came across is that it's actually more efficient to store data in SQL Server and then query that, using filters and whatnot, like where clause, to query the data and only pull back what you need, than it is to maintain a list of information in a data list inside of Power Automate Desktop. Looping over lists is extremely inefficient in Power Automate Desktop right now. Those are some of the things that I have learned. I'm going to click no, we don't want to keep playing. Those are some of the things I've learned while building this. This was a lot of fun. It was very frustrating. It took me a lot of time, probably more than 60, 80 hours I spent on this. I probably made 5, 6, 7 different working versions of this flow that just work entirely differently from each other. If you're here just to see demo stuff, you'd like to see this run a little bit more, now you can probably skip to 15 minutes to the end of the video. Just look for a chapter, go straight to that if you'd like to see more of this demoed. But if you're interested in seeing the detailed explanations and me walking through what I've built, I'm going to do that next. But I won't actually be building anything this time like I would normally do on these videos. I am just going to walk through it. Thanks so much. Let's jump into the technical part of the video now. Welcome to the technical part of the video. There's a lot in this flow. Okay, you can see there's a bunch of subflows here. There used to be a lot more before I refactored and made it more efficient. So to start with, let me point out the whole point of this is to solve Minesweeper. So you go download a Minesweeper game. If you were going to do this for yourself, let's say, look up Minesweeper X. That's the app that I downloaded. I think I renamed the executable to just minesweeper.exe. So I'm going to open up that. So here's Minesweeper on my screen. What I want to do is automate this. So if I were to just click it, let me switch to beginner. This will be easier for me to play around with. If I left click, then it's going to open up a tile, show me something underneath. I can click again, click again, click again. Eventually, if I just click randomly, then I will click a mine and that explodes and now I've lost the game. The point is to sweep the field, to find all the mines, mark them as flags, and then we have solved the game. So in this example, you can see a bunch of ones, right? The ones are the easiest to deal with. So the concept is you look at a particular number. So this is a 1. This tells me how many mines are in surrounding tiles around that 1. In this case, there's only one new tile, which is what I'm calling these sort of initial tiles that show up on the board when you first create the game. That I'm calling that a new tile. So I know that that has to be a mine because there's only one new tile in this area and there's ones telling me that there's one mine nearby. So I'm going to right click on that. And then I just do the same thing for everything else, even 2s, 3s, etc. So in these cases, there's a bunch of ones. So let me take care of those. I'm right clicking to make these flags happen. That's the same thing the bot will do. When it comes down to something like this, right? If you see a 3, that means 3 of the nearby tiles are mines. Or if you were to click it, it would open up and there would be a mine there. We would lose the game. So I need to right click all of those mines. In this case, you see that of the 8 mines around this 3, there's only 3 tiles at all that could be mines. 2 of them I've already marked as flags or as mines because I used these ones right here. There's one more left though, so this is very similar to some of the rules that we'll have processed in the Power Automate automation itself. So I know that this has to be a mine as well, and then I can keep processing. So this 2 tells me that there are 2 nearby mines. There are only 3 tiles where there could be mines. I've already marked 2 of them as mines, so I know this last one is not a mine. And then I could just keep processing that until I eventually solve the game. And just like that, we're going to have to guess a little bit here. Same thing with the bot. It will end up having to guess. Now, there is a rule that I can process here that I did not build into the flow. So I'm cheating a little bit because it's too complex for me to think of how to build that. And now we've won the game. So that's Minesweeper, and we're trying to accomplish that in Power Automate Desktop. So as far as I know, there is no way to select these individual tiles, right? So if you're used to going into add UI element and then you hover over something and you add it, you won't be able to do that in an app like this. Why is that? I don't know. I barely understand application development. I've done it some, but like I don't think I know enough to understand why a UIA mode would not be able to interrogate this, or active accessibility. I don't know what the reason is, but for whatever reason, we can't. And that's fine. Maybe there's a way to do it, but I'm not super worried about it because it's exciting to me to try image related automations. So I'm going to cancel this. So the only thing left to us then is image recognition. And Power Automate Desktop within the last year or something has a bunch of image related actions that were added to it. And so you can capture images. So what I did is I captured images for every single image that can occur. So obviously this new tile is one of the images. I'm not going to spy it super carefully at the moment. For all of these, I just wanted to show you as an example. So you left click at the top left, or really wherever you want to start the square, and then you do a square like this. There, I think I got it perfect actually. Click OK. Okay, so you can see that the one that I just did is called image 2 right here. And that looks just like, okay, it looks like I may have done it slightly wrong as far as the width and height that I want to do with the image. That's something that took me quite some time to figure out. I mean, hours, where I was trying to decide exactly how big I wanted the images to be. And what I mean by how big or how small is that you could choose to capture an image like this. So let's say I wanted to capture this smiley face. I could choose to capture just like the inside of it, like this or something, right? So it's very small, right? It's not the entire image. And that's typically how you'd want to do it. I first started doing image related or image based automation in Blue Prism using surface automation. And in there, one of the best practices is make the image as small as you can so that it's less likely to fail at runtime. The fewer pixels that you have involved, the less likely that the colors will be wrong at runtime and whatnot. So I'm going to cancel that. So instead, in this case, there are times where I have actually just captured the entire area like this. And this is, I'm not going on it perfectly right now because it's somewhat time consuming to do it perfectly. But you can see basically I've captured nearly the entire button here. I just wanted to point out that that is something that normally you wouldn't do, and if you do, have a reason for it. But I'm just playing around with this anyway, so it doesn't matter. So I went and I just captured all of the different images that can occur, 1s, 2s, 3s. I call this a new tile when it's, the kind of image that's there when you first start. I call it blank when you've clicked a tile and underneath there's no number, there's no nothing inside that. Then we have flags that represent, I've marked this as there's a mine underneath this tile. And I think we've captured a few others. So like the win and loss condition. So if I were to just click a bunch, you can see this, the smiley face turns into a frowny face. It gets sunglasses whenever you win. And I think the only thing left is that I did do something a little bit special. You can do this. There are several ways to accomplish this, but the way I chose to identify the size of the game board and to start off determining what the dimensions are of the game board is I captured this image at the top left. And that looks right, like, let's see, right here. You can kind of see that. Yeah, I think you can see it. This looks like that image right here, just what I'm mousing over. And then I did the bottom right, which represents this down here. Finding those images at runtime tells me where the X and Y position is of the top left of the game board and the bottom right of the game board. And then I can use that in different ways. The next thing I want to point out is that how I'm trying to solve this, okay? So I need to loop over something, right? Anytime you have an automation where you have a bunch of individual things you need to do something with, typically there's no way to avoid looping over them in some fashion. So I went through a number of iterations, as I said. Eventually, I decided to go with what Jason Salmani suggested, which is to use SQL Server to store references for every single tile. I'm going to open up SQL Server and show you that for just a second. So here is a table. It has fields, row, column, type, and processed. I use those throughout the game to kind of reference this and determine a couple of things. So if for example, I want to know what kind of tile row 1, column 3 is. Right now it's a blank, right? If I don't know what that is though, Power Automate needs to know what that is right now. Is it a number? Is it a flag? Is it a new tile? What is it? We've got two ways to do this. We can either use image-based recognition, image-related actions to determine what's here, or two, we can have already known, because maybe we've already checked this in the past, probably by image-related actions, but we stored that somewhere and then we could just look it up. So it's kind of like if I glanced at the whole board and then I just throughout trying to solve it, I remember what it was last. And this is a really big deal in cases of blank tiles and number tiles, because those never change. Same thing with flag. So once any of that has happened to a tile, it's never going to change again for the rest of that game. So this 1 will never become a 2. It'll never become a 3. It won't be a blank or anything. It's never going to go back to being new. Unless we refresh the entire game like this, those things don't change. So once we've determined what it is, we never have to use image-related actions again to determine that. So that's what I'm going for here with the tile type. So you can see this 2, 2, 1, blank, 1. Those will never change again. The ones that will change are the ones that say new. Anything that's a new tile will eventually change because I will either right-click it or I will left-click it, and it will change to something else. Then the last one is tile processed. I used this to help me with, as I said, we need to loop over something. So what I've chosen to do is loop over the number tiles. And what I mean by that is in a loop in Power Automate to look at this 2, then look at this 2, then look at this 1, then this 2, then this 2, then this 1, then this 1, then this 2, then this 2, then this 1, and just go over the entire, all of the numbers and try to process them, meaning look at the nearby tiles and see if we can click on any of them, left click or right click. And after we have, processed one of them, meaning that it's no longer useful to us, I can mark it as tile processed and I never have to deal with it again. And that makes our flow run more efficiently as time goes by in the same game. And I can point out an example where I would mark it as processed. So this 1 right here is useful to me right now because there's a new tile next to it. So I'm going to right click on it though now because I know that means there's a mine right there. Well, now that I've marked this, now all 8 tiles that are around this 1 are no longer useful to me. I don't need to click on them, at least, let's say. So these other 8 tiles are potentially useful, but they are useful apart from this 1. So I can mark this 1 as tile processed. And so I would change this value to, well, I guess I would change the value to from 0 to 1. 0 being unprocessed, 1 being processed, as kind of a Boolean-like thing, even though it's technically a bit data type. Right, so that is our reference. And so what I'm trying to do is to just go like this. So let's say I'm looping over the number tiles. I'm looking at row 1, column 4, which I can see as a 2. So let's say that my target is row 1, column 4. Okay, so that's what I'm going for with this 1, 4, row 1, column 4. And what I need to know, though, is all of the tiles that are around it. So as an example, I need to know what the 1 is below it and to the right of it. So let's determine both of those. So let's say below is a 2 and to the right is a blank. The left is new, lower left is new, and then I guess we could go with lower right is blank. So I've determined all these things, that these are all in relation to this specific row and column. And once I've looked at all this, I can then categorize them. I can say, okay, well, we've got 2 new, so let's put them down here. We've got 2 blank, and we've got a 2. For these simple rules that I ended up implementing, I don't care about this 2, so I'm going to delete it. I also don't care about these blanks, so I'm going to delete those. The only ones I care about are flags and new. In this case, we don't have any flags. I can process rules based on this, all right? So the target, which is, I should probably put this, the target is the number 2, and I know that the only things I care about near it are the ones to the left and lower left, which are both new tiles. So a rule I can process is that if the number of new tiles equals this number, then I can right-click both of them. It's just a rule we can do in Minesweeper. So this is a 2. The only 2 tiles I care about that are nearby are these 2 new tiles. I can right-click both of them, and now they're both flags. And now I can update SQL Server so that both of these new tiles have now been changed to flags, so I can update that. And then I go to the next one. So this 2 right here would then be processed next. I would say, okay, that's row 2, column 4. I would look at the 8 tiles around it looking up in SQL Server. And then I determine, oh, this is one that I I've already processed. I don't have to do anything with this because these flags have already been clicked. So then I would mark that as a process tile. I would go to this 1. Can I do anything with this? No, I probably can't do anything here. Go to the 2 and move on. And then I just keep looping through all of them. So that's the concept that I was trying to implement. So the way that I did this, the way that I implemented that logic was to just do some basic stuff to get Minesweeper open. I'll just show you that page really quick, right? You can see if the process is not running, then I run it, then I move the window, and then I focus it. That's pretty simple. Let's go back to the main page. Then I get the dimensions of the board. That's important because this is image-based recognition. I'm using X and Y positions. I've got to know exactly where the window is. This is going to be kind of complex to look at, but I'm going to go over a couple of major concepts. The major ones are that I used custom objects for both the window, which is the whole thing, and then the board, which is just this area where it's just got the tiles inside of it. So I determined this at the beginning of the game, and it stays the same the rest of the time. Initially, I just initialize each of the variables inside here as a 0. Note that I could have made separate variables. I could have made a variable called window left, and that would hold maybe an X position. I could do window top, that would hold a Y position. Window right, window bottom, window width, and window height. But I chose, when I refactored this, to make it a custom object with basically separate attributes or variables or fields or whatever you want to call it. And so at any point that I need to use this, I just type, obviously in the percents, window.left, window.right, window.width, so that I can reference any of those things. And that way my variables pane, this flow variables, is way less complex because I have like window, like right here. I have this one variable instead of 6 different variables or something. Same thing with board when this references just this area. So what's the width of this area? What's the starting left position, the top position, stuff like that. And so I'll show you that quickly. Left, top, right, bottom. And then I also have the row count, which I do a little bit of math lower down in this page to determine what's the number of rows, what's the number of columns. And then I use that throughout the flow to determine if I want to look at a certain row, at the entire row, or I want to look at just an entire column. If I want to be very efficient with it, right? I can jump to a specific row or jump to a specific column or whatever it is. And so this is helpful to have. And then I'm not going to go over any of these details. I think it's relatively simple, maybe a little painful to explain though. I get the details of the window, store that into the custom object. I use move mouse to image anytime I want to determine the location of a certain image. This is not always useful, and I probably would use it a lot more if not for this issue right here. This occurrence input is a static input. You can hit these arrow keys, or you can type a different number. You can click on the 3,000th occurrence of a certain image, and it works really fast. It's really good. Eventually, though, Microsoft needs to make this occurrence input a variable, right? This just it can't be a static input forever. It's not useful enough like it is. How do I know if I want to click the 5th instance of an image? Like what? So this needs to be a variable eventually. If it were variable already, this flow would be so much easier. Oh my goodness. All right, so I used that a few times. I guess I should point out though, the real benefit of this that I found is that it outputs the X and Y position, right? So it just jumps to an image, and then it also gives you the X and Y position of wherever it jumped to. That's super useful. And so I use that throughout the flow. And then that's all I want to point out on GetDimensions. We're back up to main. I'm going to jump into another subflow. All right, so I have a subflow called setup, and the whole purpose of this is just to set up SQL Server. So we set up a connection. I think you and I both know connection strings are super painful to deal with. I will point out that initial catalog is the name of the database. In a SQL Server instance, I have locally created, and that's right here. So here's my SQL Server instance locally. This is the developer edition, I think. Here's my databases. Here's a bunch of Blue Prism databases that I play around with. They're just locally created. This is the database I'm using here. I just created a database by right-clicking, doing new database, creating it. And then it has this table, Minesweeper, and that has 4 fields in it. That's what I use for references for what the tiles are. So once I've determined it by image recognition, I can store what the tile is in here, say tile type 2 or 1 or blank or whatever, and then I can use that for a little while for the rest of the game. Because that changes between games, so when I click this, it does a new game, I drop the table every single time. And I do want to point out that this would throw an error if the table doesn't exist already for some reason. Say this is the very first time you're running it. Well, I do have on error continuing the flow to go to the next action on all errors. And then I create the table using, I'll just go ahead and show it on screens in case you're interested. Here's the query that I'm using to create the table with the specific columns and their data types. Notice I use bit instead of Boolean because I guess Boolean doesn't exist in SQL Server, and 0 or 1. So 0 equals false, 1 equals true. When I'm looping here, the point is I just want to loop so that I can get all of the numbers for the rows and all of the numbers for the columns. When I loop over this, it depends on how many rows and columns there are. So like I said before, when I got the row count and the column count, I'm using that here, and I'm directly referencing that custom object, board.rowCount. I find that so elegant to use it this way, and it feels great. So I will be using custom objects a lot more in the future. So up to this point, let me bring you back to where we are. Okay, we have, if I were to bring back everything, right? So we've displayed a message. We have clicked yes or no about whether or not we want to play. And then we have opened up Minesweeper on the screen. It's gotten the dimensions of the entire window and the board, which is just a small subsection of the window. We've set up SQL Server. And then I use ifImage a number of times throughout this. So let me talk a little bit about ifImage here, and then I'll try to not talk about it as much later on. Why am I doing ifImage here? Why am I doing ifImage here? I actually forgot. I wanted to support, what if somebody's already started the game and then we run the flow? It should be able to continue from where we left off. Otherwise, I wouldn't need this at all. But the idea is we want to start the game by either left-clicking this tile just to get started, or let's take a look at the whole game board, figure out what has been clicked and what has not, and then continue from there. So that's what these two paths are. So if we find one of these images, 1, 2, 3, 4, 5, 6, 7, 8, or a flag anywhere inside this window right here, and keep in mind, I'm just searching inside this area. In that case, we want to refresh the board reference. So SQL Server, when you initially set it up, when I run those queries and create the table, I'm putting the word new in as the tile type for every single tile because I'm assuming this is a new game. Well, in this case, it would mean this is not a new game. Somebody's already started clicking on it. So what we want is a subflow that looks at every single tile again and tries to be relatively efficient with it if we can, and then updates SQL Server on anything it's wrong on. So in this case, it would update all of the first row, all of the second row, and some of the third row. More I want to say about this ifImage action. I did not like using foreground window only. It seems like an okay option to have, but it's just not great. What I'd like to have is a third option. So you could tell it, look inside of this specific app, or look inside of this specific UI element. That seems like something that's missing from here. But it's not a huge deal because what I can do is, like I said, I can look at where is this UI element? Oh, okay, well, here's the XY positions. And then I can use that by checking for entire screen. I can search in the entire screen, but my search mode is on a specified subregion of the screen. And then when I choose that, as opposed to doing the whole screen or the foreground window, using the XY positions. So X1 would be the left, X2 would be the right, Y1 would be the top, and Y2 would be the bottom. That tells us our dimensions, right? So we would just look inside that area. So what I have it doing is using the board.left, board.right, board.top, and board.bottom. Again, super elegant use of custom objects. I really like this. And then two things I'll point out. Note that with the X2 position, I have added 1 to this. That's because X2 appears to be broken. I've reported this to Microsoft already. I don't know if they're looking into fixing it or not, but I've reported it at least. And all of the others, X1, Y1, and Y2, seem to function exactly like I would expect them to. But for some reason, if I tell this the far right pixel, right? If I tell it this pixel right here, from the left side of the screen over all the way over to here, tell it that X2 position, it won't properly find images in that area. I have to go 1 pixel to the right. So I don't know if you could tell, I moved my cursor slightly to the right. So I have to tell it 1 more pixel to the right, and then it will work properly. And so, if you're using ifImage, just recognize it probably won't ever matter for you because you're not likely to be searching in such a very tight specified subregion. But if you are, you may want to add 1 to the X2 if you run into any issues. And then the tolerance I have set to 0. The reason I've set to 0 is that there are grays all over this. And this is dealing, I guess it doesn't say color tolerance, but that's probably what this is. This is talking about like the RGB values when you're comparing one color to another. And you can see these grays are very similar to each other. They are within 10, and that's the problem. So I had to just change this to a tolerance of 0. I have it very strictly find the images that match the ones I've spied, the ones that I've captured, and that works great. Now, you'll probably have to play around with this, especially if you use this for production purposes. You'll want to really test out the color tolerance here and make sure that you've got it configured correctly. And then the image matching algorithm, I have always used basic. I believe if you look up Microsoft's documentation, it'll say something about less than 200 pixels, you'll use basic, and more than 200 pixels, you'll use advanced. And I've used basic. It seems like it's pretty performant. It has never failed whenever I've built it correctly, especially after I fixed this, right? The X2 position. I thought something was wrong down here, but it was actually just the X2 position. Okay, so I talked a whole bunch about the if image action. I'm not going to go into that much detail ever again when it's an action that looks very similar to that. So if the if image action turns out to be true, any of those images exist, then we're going to refresh the board reference. I will come back to that and show you what that means. But for now, keep in your mind, that just means look at the whole board and update SQL Server to make sure that it understands what is correct about the type of every single tile. Then if none of those images are found in the screen right here in this subregion, then we're going to just set our target to be row 1, column 1. And then note the only reason I have these as set variable is that you can't do input and output parameters to a subflow. Otherwise, these wouldn't be here. And instead, I would use an input to this LeftClickTile. I would type in 1 and 1 as far as the inputs. I would love to have inputs. I would love to have scope for variables, but that's just not a thing yet inside of a single flow. Now, I know that you can use separate desktop flows for that, but there's reasons why I didn't do that here, and it all comes down to efficiency. I tried this a whole bunch of ways, trust me, and I've set these global variables, row and column, to left click on a tile. And then after it's done one of those things, right? It doesn't matter which one it did. It will either have left clicked like this, or it will have determined that somebody else has already clicked on this. Then it's going to just go into a loop, and it's going to loop over all of the number tiles it sees on the screen, process some rules, take some action, and keep doing that over and over until it solves the whole thing. So with that, let me show you some of the subflows before we get into this, because I think it's important to know what those subflows do, even if you don't see exactly the details about them. So let me just pick some of these to go over. Get XY by row column, I think, is an important one. Before I call this subflow, which I reuse it in a number of places, so I'm going to right click, click find usages. You see I call it on RefreshBoardReferences, LeftClickTile, and RightClickTile. Those are 3 separate subflows that reuse this same logic. Before I call on this, if I were to go to any of these, right before this, you would see set variable column to a number, set variable row to a number. Then inside of this subflow, it is dependent on this column variable and this row variable having already been set. And then it sets the XY positions and then the center of the tiles to whatever, the positions are on the screen. So just to be clear, when I say the X and Y positions, this X1, X2, Y1, Y2 will make a square that is just the size of a tile. And I think how I have it working is it's actually slightly bigger than the tile. So then whenever I go to determine, like with if image, for example, I can determine if in this specified area, so X1, Y1, and X2, Y2, is inside of this, is there a 1, is there a 2, is there a 3, etc. And then with X center and Y center, I do that just in case I want to use it. In this case, I use it to actually click the middle. So I can click the very center of a tile because I've set where that center is right here. All right, that gets reused a number of places. Let's go to get tile type by image. In this case, I have already used the get XY by row column. So if I'm going for, say, for this one right here, let's say that I want to determine what kind of tile that is, because I need to use image recognition because I haven't looked at it since I clicked it. So literally, let's say I just left clicked this and it exposed a 1, and I need Power Automate to read it by image. So I have already set the X and Y position. Then I call on, this get tile type by image subflow, and it uses our if image action, which I've already gone over, and it uses x1, x2, right, with that +1 like I mentioned, because it doesn't work right. Y1, Y2, color tolerance of 0, and it tells me whether or not there is a new tile here, right, because I've plugged in new tile. If that turns out false, then I go to the next one. Is this a blank? Okay, no. Okay, is it a 1? No. And then I just keep doing that for all of these. Go 1, go 2, and then I just do that for 3, 4, 5, 6, 7, 8, 9. Oh, I guess we don't do 9. There's no 9. And then we look at see if it's a flag. So it should be one of those pretty much all the time, unless we've lost the game already. So I will determine which one is correct. There is, just to mention, there is no if else image. There is only an if image, and you could use an else inside of here. The way I've built this, though, is to short circuit the logic. So if one of these turns out to be true, I have forced it to leave the subflow by first setting the tile type, right? If it found a new, then I set tile type to new, exit the subflow, and it goes back up to whatever flow called this. And then all of these had the same repeated logic with it, exit subflow. All right, LeftClickTile and RightClickTile we should probably talk about next. So actually, let's go to RightClickTile. That one's a lot easier to understand. Okay, so RightClickTile uses one of the subflows we just talked about, get XY by row column. So in this case, whenever I go to right-click a tile, now remember I said I always set the row and column number right before calling this subflow to get the X and Y positions. Just note that I have carefully gone over this entire thing, and before I call the RightClickTile subflow, I have already set my target row and column, so I don't have to worry about doing it here above this. It goes into here, gets an X and Y positions, right? The top left to the bottom right and all that stuff. And then I right click, so I'll open up send mouse click. Right click is what I've chosen for the mouse event to send. I don't wait. We do move the mouse, and then the X and Y positions. So if I turned that off, it would just turn off all the parameters, by the way. So X and Y positions, I use the X center and Y center because I like to see it click in the middle of the tile. It looks weird to me if it clicks the very bottom right or top left or whatever. So I have it clicking in the very center. And then what is it relative to? Well, all of our measurements, all of our X, Y positions are relative to the top left of the screen. So I've chosen that. And so actually I love this action because it tells you the X and Y position of your mouse. So I could go move like here, put my cursor right there in the middle of that tile. And it says the X position is 70 and the Y is 141. So that's the numbers that we would have gotten back by saying, what's the Y center and X center of row 3, column 4? And it would return back those numbers, and we'd use that to click. Mouse movement style is instant. So that's send mouse click. I'm gonna gloss over some of the set variables that I have it using in order to control the flow on other subflows, and that's related to Power Automate having global variables. That's the only reason you see that here. After every time I right-click a tile or I left-click a tile, so let's say that I want to right-click like this, I have now changed the type of the tile that's right here. So I'm going to update that. Now, in this case, I don't need to read it by image recognition, right? So that's why I don't do get tile type by image, because I already know. I just right-clicked, so it's obviously a flag. So I use the SQL statement, update Minesweeper, set the tile type to, in this case, it'll be flag, because I've just set the tile type to be flag, and then where the tile and row match. And I don't think I've mentioned this in other places, so I wanted to point out here, I turn off the variable output anytime I don't need it. I don't want the variables pane to be a pain. So I turn off the variables wherever I don't need them. And then let's jump over now to the LeftClickTile subflow, which I think I use in a couple of different places. This does similar things to the right click, except the logic is a little more complex. So whenever I want to left click a tile, same thing, I need to get the X and Y position of the row column. Every time I call on the left click tile subflow, I always set the row and column by using set variable for row to 1 or 5 or 8 or whatever. Same thing for column. Then I do the send mouse click. This is the same thing as the right click, except that I'm using a left click here. I still do the X center, Y center, and relative to the entire screen and instant mouse movement style. The difference here, though, is because when we left click, we could cause the game to end. And I'm going to show you here. When I left click this tile, it is going to cause a failure because I know that this 2 tells me both of these are mines. So when I left click, boom, this caused a lose condition. So immediately after I have left click, I check for a win or loss condition. I'm going to jump over to that really quick so you can see what I have. It's pretty simple, I think. Yeah, so this just checks to see if the continue image, right? If it doesn't exist anymore, meaning this the smiley face has changed, that means we've either won or we lost. So if that doesn't exist, then we check to see, does the win condition exist or does the loss condition exist? If either of those do, then we are going to set the end condition to win or to lose. And then I have various checks on all of the pages to see, has the end condition happened yet? If it has, then it exit the subflow, exit the subflow, exit the subflow till we get all the way up to the top in the main flow, and then we will, either end the game or restart or whatever. So let me jump back over to LeftClickTile. We've gotten the XY position, we've clicked it, we checked for the win-lose condition. Let's say that we did not lose and we did not win, right? This is not the end of the game. If it were, we would exit the subflow. Okay, so we'll continue. We need to get the tile type of the image, right? So like if I click here, boom, I don't know what that new image is now. I don't know what's underneath this. If once I read that, if it's like a 1 or a 2 or 3, whatever, then it's simple. We're just going to update SQL Server, similar statement as earlier, with whatever the new tile type is for that specific one that we left clicked on. Now, the difference is if it's a blank, then we want to check really the entire game board again. And the reason for that, let me do it a couple times. You'll see every time that a blank shows up underneath what I click, like here, all of this opened up. And because of that, you kind of just have to check the whole board again and re-verify everything. We have not gone over that subflow yet, but that's that refresh board reference. And we'll go over that in just a little bit. Okay. So in the case that it's a blank, we are going to refresh the whole game board. If it's not a blank, then we don't refresh the whole game board. We just update that one specific tile. Let's see. The only ones we haven't gone over yet are TakeAction, GetNearbyLists, LoopNumberTiles, and RefreshBoardReference. So let me go ahead and go over the RefreshBoardReference with you. This is logic that I've built so that you could call it at any time, right? Anytime you want to refresh the entire board reference, you can do that. It will make it more inefficient though, the more times you call it. So I try to call it as little as possible. Every time that you saw me demo this automation, you saw it waiting. Anytime it wasn't really doing anything for a period of 10 or 15 seconds, this is the subflow that was running. Because the idea is when a blank tile shows up, I don't know which ones have changed. It could expand out this way. It could expand out this way. There's just no way for me to know. So I've got to look at everything. I have implemented a few pieces of logic in here that make this more efficient. I'm not going to go over it in specifics. I'm going to just kind of let the screen show while I explain this. And I don't think that you necessarily ever need this logic. I think that you could come up with your own too, but I just wanted to share with you my concept. The first concept for making that more efficient, as far as like, I could look at row 1, column 1, row 1, column 2, row 1, column 3, row 1, column 4, row 1, column 5, row 1, column 6, and I could just loop through all of the tiles and make sure all of them are correct, and then update SQL Server if they're wrong. The problem was that that's just super inefficient. And so I implemented a few things to make that more efficient. The first thing is I first check to see when I'm looking at a certain tile, let's say this top left one, have I already looked at that this time? So during this session of refreshing the board reference, have I already looked at that? And the way that I determine that is by just strings. So I create like a text variable that contains text like R. Let's say C1 for column 1. So have I already looked at this tile or any of the tiles in this column? If I find C1 inside of that text variable, then it means I've already looked at it. And then I can go back and look it up later. So again, I'm kind of glazing over this, but I just want to explain the point is I use text variables to store whether or not I've already checked a certain column or a row. When it comes to certain tiles, right? Let's say that I check this whole column, then every single time I look at any tile in this column, I can immediately know from the variables that this entire column is new. Why? Well, I came with this ingenious concept. I'm sure it's just a simple concept to some people, but I was like flabbergasted with myself. That's a technical term for surprised at myself that I was able to come up with this. And the idea is I put the X and Y positions so that it surrounds this entire column. And then I use an if image action to see if any of these numbers exist in that whole column. If it comes out false, right? No ones, no twos, no threes, no whatever, that means they're all new tiles. And so I never need to use image-based recognition again for that entire column. Same thing for this entire column, same thing for this entire column, and then this whole row, and this whole row. The first time I check the whole row, after that, I never need image recognition again. However, with all of these, right, all of these like blanks and the twos and whatever, nothing we can do about that. It just has to look at every single square here, determine what kind of tile it is. Oh, there's a blank tile, blank tile, blank tile, and then update SQL Server each time. Now, that actually turns out to be relatively efficient though, especially when you're doing something like this, right? When you're doing a big game board, this kind of logic is super efficient especially once it gets down to having solved a bunch of the game board. It goes through and loops over faster and faster because it's better at guessing or determining, what has and hasn't been checked already. So that's my refresh board reference. As it identifies that something has changed, then it does an execute SQL statement here, like update Minesweeper, set the tile type, and then wherever the row and column matches. That's my refresh board reference. And that's, again, where it kind of stutters, right? When it's like solving and it pauses for a while thinking. Really, it happens every time that a space opens up like that. That's when refresh board reference will be triggered. Okay, now we have gone through most of the subflows. The only thing left, I guess, before we talk about the main part of this is GetNearbyLists. So concept here is the same as what we were talking about when we were dealing with Notepad. This is my GetNearbyLists concept. Whenever you have a target like row 1, column 4, and let's say that in row 1, let's see if we can get that to not be, okay, here. So row 1, column 4 is right here. It's a 1. So let's say our target is a 1. Here's our reference as far as like where that is on the screen, row 1, column 4. Then we need to know what the 8 tiles are around it. So it would be like upper right, etc. And we just determine what all 8 are. And then we determine how many of those are new tiles, how many of those are flag tiles, and based upon how many we find, we can process different rules. So the way that I implemented that here is that I created I think this is actually not a custom object. This is a data table. I think once you run this, so I'm going to go ahead and run this because I think that this is a data table, not a custom object. And I don't know until we run it. Okay, so here, tiles surrounding is the name of the variable. Okay, yeah. So this is a data table. And whenever I loop over this, what's going to come out of it each time is a data row, tile surrounding. Yeah. The concept here is we do what I said here, right? We determine for a target tile, we determine what all 8 tiles are around it. Note that in this case, the ones that are above it are outside the scope of the game board, right? And I have the flow determining that. If the tile that it might look at, like this upper left, upper or upper right, it's just going to come back and say that it's null like that or something. And that way I can ignore it. Because remember, I only care about new tiles and flag tiles. I don't care if it's outside the scope or whatever. I don't have it using image recognition out here. And then there is a little bit of a complex concept I've implemented. I don't know that I want to fully explain that here, but in case you're just like, what's going on there? I have the target row column, let's say row 1, column 4, using the values that are in here. You add -1 to the row, and you add 0 to the column, and you get the row and column position of the tile that's upper. I'll pick another one in case that was unclear. So let's say that my target row column is 1 and 4 here. Then the row and column number for the one that's just below is going to be adding 1 to the row, so go from 1 to 2, and adding 0 to the column because we're not changing the column. And so that's the sort of relative reference, so the row and column offset from the target. I know that might be confusing. Don't worry about it if you're like, what? Just keep this in your mind that the point of this is to basically store the information I need in order to reference surrounding tiles. All right. Once we have those surrounding tiles, then we look at each of them and determine, is this a new tile or is it a flag tile? If it's a new, we add it to the new list. If it's a flag, we add it to the flag list. And you can note that what I actually store is a row and column inside of each of these, so that if I determine that I can process rules where all of the nearby new tiles can be clicked. I can left click them all, or I can right click them all, or whatever. Then I can just loop over this list and I can click each of them and I can use the row and column references. Might be confusing. If that's confusing, don't worry about it. I also confused myself for hours. So I'm just trying to give you something rather than just breeze over this and say nothing about it. All right, let's jump back up to the main page really quick and say, point out, let's say this thing is running. We've opened Minesweeper. We got the dimensions. We've set up SQL Server, refresh the board reference, or left click the top left tile. Then we're just going to loop through all of the number tiles that we see. In this case, we only have 2 number tiles, 1 and 1. So there's not much to do. But let's say it's more like this, right? We have a bunch of number tiles. We need to loop through all of these. SQL Server can pass that to us. So let's go into the Subflow LoopNumberTiles. We are going to execute a SQL statement to get all of the number tiles. So select all of the fields from the Minesweeper table where the tile type equals 1, 2, 3, 4, 5, 6, 7, or 8. So that gives me basically references to all the tiles here that are numbers. None of the blanks, none of the news, none of the flags. And I also further limit it by ensuring that the tile processed is 0. And in this case, remember, this is false because SQL Server doesn't have Boolean. So this is like false and 1 would be true. And then it produces a tiles number data table. And then we loop over that data table right here. And for each of those number tiles, then we'll get a few details about them. We get the nearby lists, right? Remember, I just went over that. We determine for a specific number tile, what are all of the tiles around it? And we are checking with SQL Server, not using image recognition at that point, because we've already looked at all of those tiles. We know what they are. Once we've gotten the nearby lists, we're ready to take action. So we go in another subflow. So let's go down to take action. There, I'm gonna minimize these. Okay, this is gonna take a little while. This is something that I don't understand why this takes forever, but it's so painful. I never want to use the drop-down buttons. I clicked on that as soon as we got into that page. Okay, ready? I'm gonna click this. Let's see how long it takes. I'm not gonna cut any time out of this. Power Automate, it's all on you. We're waiting on you to finish this video. It's still going. It is still going, not responding. And there we go. Okay. So I just wanted to show you the high level view of this, but Power Automate is still extremely inefficient in certain ways. All right. We have an if, 2 else ifs, and an end. In this case, the very first one is very simple. The idea is if there are no new tiles nearby, then I've already processed this one entirely. So let me just change the game board slightly. So I've changed this to a flag tile. This one is completely processed. There are, of all of the 8 tiles around it, none of them are new tiles anymore. Because of that, I can consider it processed. So I run a SQL update query that updates, let's see if I can drag this out so you can see the whole thing. Update the table, set the field tile processed to 1, meaning true. So we've already processed the tile where the row matches and the column matches. And that way I never have to look at this one again. So next time I use this SQL query that we did on the flow right above this, when we queried all the number tiles, it's not going to return this one ever again because it's just pointless and wasted time to look at it. So that's one of the efficiency improvements. So if that's not true, right? If there are in fact nearby new tiles, then we need to determine one of 2 things. Either the number of nearby flags is less than the number of that tile, meaning, as an example, let's say that our tile is 1, then that's just not a good example. Let's say that our target is a 2. Then if the number of nearby flags is either 0 or 1, then we're going to go into this else if. if the number of nearby flags is equal to the target, so like let's say our target is 2, so if there are 2 flags nearby, let's say like this and this, then we'll go into this else if. If none of those apply, then we're just going to go past this and we don't do anything. In that case, we would basically not be taking action on whatever number tile we're on. So let's say that we went to this number, we didn't process anything. That means none of these things came out to be true. This one, none of them turned out to be true. This one, none of them turned out to be true. We went to this one, none of them turned out to be true. We went through the entire list and we didn't do anything. In that case, I have it set up so that, oh, we basically can't do anything. We're like, even like a person, right? We can't process any rules. I don't know what to do. So we randomly click a tile. Now, in the case of the bot or this flow, it's just going to click the very top left new tile in the game board. So in this case, it would be this one. And it's just going to keep doing that until eventually, when it loops over all the number tiles, it has something it can process. So let me expand these. I don't know how painful this is going to be. I'll probably just cut out the time if it takes a long time, but here we go. Yep, it took just as long to expand this as it did to collapse it. I don't know that I want to completely explain this logic because I don't know that you necessarily care, but I do have a statement here that uses, this is one like true or false statement. This is another true or false statement. And both of those have to be true in order for us to go into this part of the if. And in this case, we would basically be, right-clicking all of the new tiles, meaning, if this logic doesn't make sense to you, let me show you a situation where that would actually occur. Let's see. So this is to right-click all the new tiles. So here's an example. Let's say that our 2 is our target. In this specific situation, as you see it right now, if we were looking at this 2, it would go into this else if, it would go inside of this if, and it would go into this for each, and it would run this. So it would go, well, we don't really care about the splitting part, but it would right click on any tile that is around this, every single one of them, because there's only 2 new tiles. So I'm going to right click. That's what it would do here. Now for the other else if, I'm going to click this and we're going to come back after this is done expanding. Okay, we're back. It did, in fact, take a long time to expand again. For the next else if, to make that actually happen, right, a situation where our target's tile would go into this logic, is if we were looking at this 2. So this is row 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5 column. So row 6, column 5. This 2, if we were looking at that, because remember, we loop over all of the numbers. In this situation, it would see that the number of nearby flags, 2, equals the number of the target tile, which is 2. And so our rule is, if you find that, then you can left click all of the remaining nearby new tiles. So it's going to loop over all of the nearby new tiles, and it's going to go left click, like that. And so all of those are safe to click on. And for each of those, it needs to update, right? Technically, I think how I have this working though, because anything can happen when you left click, right? Like a blank tile can show up underneath. I don't want to get into detail with this actually, but I don't technically have it clicking all 3 right away. It has to come back and reprocess that same tile again and click one tile each time, because we have to check the game board to make sure we haven't lost or won in between each of those. So anyway, but that's what this logic down here is for. And that is how we take action. Now we go back up to LoopNumberTiles. If when we take this action, we win or lose, then we'll obviously exit the subflow and we'll, go back up to the main flow. If we haven't lost though, then we check to see, has any action been taken? Now, every time you left click or right click, I have it setting the action taken variable to true, meaning that it won't go into any of this. However, if you go through all of the number tiles and none of them can do anything, we can't do anything with any of them for an entire sort of session going from the first to the end, then it's going to go in here, query SQL Server for a new tile. Technically, I have it giving me back all of the new tiles. I really should do like top 1 or something, but I just didn't. It gives us back a list of new tiles, and then we just left click the first one in that list, and then we exit the subflow. So once we've gotten to the end of this, and we've processed this section or we skip it, either way, it goes back up to the main flow. We're up here. It's going to go to this, check to see the end condition, is it win or lose? If it's not, then we go back up and we just loop into the loop number tiles again. We loop over all of them again. We keep doing that over and over until we solve it. Eventually, we will come to an end condition, which will be win or lose. We will present ourselves with a display message that says, game over. Do you want to keep playing? In this case, I chose to have it keep the message box always on top, and it closes the message box automatically after 5 seconds. This lets me sit here and demo it, right? I can talk to you about it, and it continues to solve on its own because the window will go away on its own. I think that's a very awesome feature. In those like 5 seconds, if I choose to click no, then it will stop playing, and that's a very useful thing, I think. So I do have it using the output of button pressed. What will go into that is literally either yes or no. So here, if the button pressed was yes, then that means we want to keep playing, which means that it clicks, let's see. Yeah, it clicks this button right here. So it will be like if we were to win, then this button would show up here. If we lose, right, this is the same logic. Game over. Do you want to keep playing? If we send yes, then we want to left click on the lose button. So if I just click, there's the lose button. Then we would send a mouse click to the lose button, and then we would loop back up to a label. I don't like using goto statements because it's a VB.NET kind of thing or Visual Basic kind of thing. And I think C# developers and other .NET developers will probably judge me for using a goto statement. But don't judge me. It's here, so I'm going to use it. So this goto goes to a label called solve again. If I scroll all the way up here, here's the label solve again. And so it just processes all of the logic again, all the way back down. And it just keeps doing that over and over. And that's my solution. I think the only thing I didn't maybe show you is my move window logic. This is a separate flow. Let me bring that up. So if I were to do this display message, let me copy it. You can't right click on an action and run from here if it's inside of an if statement or a loop or anything like that. It has to be outside on its own. So that's why I just copied it. I'm also going to change this close message box automatically to false. And I'm going to click yes. So now I'm just going to run it from here. I just wanted to have this on screen. Okay, so I think you can see that. Yeah, we lost keep playing. I'm not going to move this. I'm going to go over to my other flow. This one just loops over and over, looking for any windows that say game over in the title, or I guess equal game over in the title of it. So I'm going to run this. It's going to wait for that window. It moves the window up to the top left. The reason I do that is when I record any GIFs. Yes, it's pronounced GIF. It's not GIF like the peanut butter. I don't care. You're wrong if you say it is. It's going to move that up to here in the area so that if I want to record my screen just in this area up here, it's moving the window up next to Minesweeper alongside it, because I don't currently know of any way to make Power Automate put the window where I want it to be. So I have a separate desktop flow running at the same time that just moves that window up all the time. And I can show you like, right, so I'll just say no, and then I'll go run it again. Let's see. I'll run this again. It'll pop up and you'll see pretty quickly it should automatically get moved up here. Now, I think in the demo earlier that I did, it didn't pop this up when I did the intermediate version of the game. Don't know why that is. It might have just been in the background somehow. Don't know what happened. But anyway, for the most part, this runs pretty reliably. Now, I guess what we could do to finish this off is let's close these. Let's stop this. And we're going to just try this a couple of times on different difficulties of the game. So let's run move window. Okay, that should be running. And now I can run this. This is the 4.9 condense. Yep. So I called it condense because I was trying to condense the code. Ignore that word. All right. So I'm going to click run. And what we should see is it say ready to play. All right. Yeah. So this is whenever I make a GIF, I normally bring this up here manually. And then I click yes. And then I'm going to stop touching the keyboard and mouse. And it's just going to run by itself. We'll see if this can manage to solve it at the beginner level. And then if you're not already used to it, I'll point out you do like Control-Shift-Alt-T on your keyboard, and that will stop all running flows. So that's what I'm going to do in order to, actually, no. Instead of doing that, I think I'll just answer no to the question when it pops up at the end here. And that way it won't continue. Okay, so we'll just, ooh, it might fail here. Okay, it's good, it's good. It's processing rules. As you can see, it's pretty efficient. And I think it's because of implementing SQL Server. Looping over lists is just terrible. Okay, we should be able to potentially solve this whole thing. Oh, looks like we're going to win. Oh my goodness, we're the best. Okay, so I'm going to hit no. I don't want to keep playing so that this stops. You should see it stop, but this one is still running, the move window. I'm going to go to game. Let's do intermediate and run this again. After this, I think we will run the expert level. We'll see. Oh, ready to play. Yes, I'm ready to play. You'll notice that the move window the move window desktop flow didn't move that window up to the top left. That's because it has a different window title. Oh, we lost already. Yeah, we want to keep playing. Okay, this one's looking better. I remember we talked about the refresh the board reference. That's what it's doing right now because it found a blank tile, so it's got to refresh the entire thing, make sure it's correct. But you saw it ran pretty efficiently, and I think it's because of looking at the rows and columns rather than looking at every single individual tile. So here, it's doing it again. It's going to look at all of the new tiles again, except that it's going to skip over all the ones where the entire row or the entire column is a bunch of new tiles. So imagine right now, if it had to look at every single individual tile by image recognition, how long that would take. I'm quite happy with how fast it runs. I really didn't think it'd be possible to ever get it to the point where I would be impressed with how quickly it runs. Now, because of the way that I have the logic happening, it jumps all over the place. Here, it's going to do the refresh board reference again. I was quite impressed with how fast it runs, but like I was saying, it goes all over the place sometimes. It will jump from the left to the right, to the top, the bottom. It looks like it's random clicks, but it's not. It's because it's looping over the numbers from the top to the bottom, and just depending on certain circumstances, it may or may not click on the tile that you as a person would go, oh, I should click on that next. Well, it doesn't see things the same way we do. It loops over in a logical order every single time that it does this. So here it's taken a little bit of time because it's doing the refresh board reference again. And in this case, it can't be efficient because all of the rows and all of the columns had to be rechecked fully. Yeah, so you can see at the bottom right there where that 3 is, there's 3 mines next to it. You could go ahead and right click that final one that's about to do right now. Right, it could have done that a while ago, but because it processes things in a different way from a person, it's just not going to do it in a way that we would logically see it happening. And I think that if I tried to race this, like John Henry or something, if I tried to beat the machine, I think that I could, but the only reason I can is that there's no quick way to refresh the entire game board whenever, like there, blanks happened again. This is the only reason that I could probably beat the bot, that I could beat this flow if I were to race against it. Because right now I could be clicking, click, click, click. I'd be clicking and I'd be doing a number of different things, but it has to go and check everything again. But imagine how long it would take me if I were trying to update like an Excel reference sheet for myself. Imagine how long it would take me to look at every tile and make sure every single thing is correct. But that's what the flow is doing. It has a perfect representation, a perfect memory of what the entire game board looks like. It's kind of impressive if you think about it like that. And look, so there's 2, I'm going to move the mouse right now. There's 2 blank spaces or 2 blank tiles right there. And those 2 blank tiles made it have to refresh and check the entire board again. But you saw it went a lot faster that time, right? And that's because one of the things I implemented is that as it progresses through the game board, it gets more and more efficient, faster at rechecking everything. So here, watch how little time this is going to take because it's only going to check the new tiles. Whatever SQL Server says is new tiles, those are the only ones it's going to check. So see, it went a lot faster than it did before. I think we might have a chance to solve this. It's going to get really close, if nothing else. Oh, this is exciting. We're going to win. We're going to win. We're the best. Oh, it's pretty exciting. So, no. Okay, I'm gonna have to do Control-Shift-T, and you'll see, should see this stop. Okay, cool. I meant to say no so that I can change it to expert level. Now, I have not run this in like a while, so I don't even know how well this is going to do, but we're going to test it now. Oh, wait, this failed. Oh, right. That's right. I told it to stop. So let's do, that's why in the demo, if you saw the intermediate, when I changed to intermediate and I tested it and I ran it against it, I couldn't figure out why it didn't move the window, right? Like the, do you want to keep playing window up to the top left? It's because I did Control Shift Alt T to stop all running flows, which meant it stopped my move window flow. Well, that explains it. It wasn't running. Okay. So move windows running. Now we're going to run this. Here we go. This is the real test. 99 mines. Are you ready to play? Of course I'm ready to play. You kidding me? Okay, so it's just clicking the top left tile because it has no rules to process. It's probably going to fail. The only way that the bot can continue here is if it manages to open up the board, right? It has to have blank spaces pop up. Yeah, so this is just going to keep failing. That's okay. This is how a person would do it, right? You would click random tiles and you would fail over and over until something like this happens. I think that it still might fail. It's going to click the top left tile here because it doesn't have any rules to process. But see, like I know which tiles I could click here without losing, but I don't know how to program it into the bot. I'm not smart enough for that. Okay, here we go. We got some rules to process. It's going to be able to go somewhere. Still not looking great, but it's got 1, 2, 3 tiles that it can do something with. All of them dealing with ones. So it's going to do that top left tile with second row, like the fourth column. Nice. Nice. Okay, it's going to do a flag on the top left new tile. What is that? The sixth row, or the first row, sixth column. It's going to flag it anytime now. It's checking the whole game board. There we go. Okay. I don't know why it clicked that. Yes, I do. I do know why it clicked that. Man, I tell you, if I had a nickel for every time I didn't know why the bot did a thing because it did it so fast that I couldn't think it through, I would have at least 20 nickels. Okay, anyways, so here, right? Blank tile comes up, it sputters and it kind of stutters, it doesn't know what it's doing. Goodness gracious. Okay, so I can see that's going to be a common thing for the expert level here. It's going to have to refresh the game board a bunch of times. Luckily, we have the row and column concepts to check the entire row, the entire column. Are you able to follow this? I'm not able to follow how fast it's going. My goodness. I can barely follow this. Okay, so if I've ever had that moment where you think robots are going to replace humans one day, I've at least had it just now. Because imagine if a human's job was to solve Minesweeper. The bot can just do it already better. Now, we would obviously need to program in better rules, but like somebody could build a machine learning algorithm so that even when it comes time to guess, the bot could take into account all of the numbers and the most common scenarios that occur in Minesweeper, and it could make guesses that would be better than what humans would do. But again, I don't know how to do that in Power Automate, so that's not going to happen here. So we will always be better than our bot in Power Automate, I think. But the problem is our bot could go 24/7. It doesn't need coffee breaks. I don't like coffee, but I do need some kind of breaks. This is actually going pretty well. I find it difficult to talk while this is happening because my brain is just struggling to keep up with the mouse clicks. Now, what I could do if I wanted to follow what all it's doing, I suppose I could change it to use a mouse speed that's not instant so that it doesn't jump to wherever it's clicking, because my eyes are having to catch where the cursor goes to. And instead I could make it move more slowly so that I could follow where it's clicking each time. And that way I could follow along with it. And maybe that'd be a cooler way to demo, but it would take even longer. So let's not do that. Okay, cool. We got another blank. Look at all of the individual groups of blanks on the screen. 1, 2, 3, 4, 5, 6, 7, 8, 9 so far. 9 times it's had to refresh the entire game board. Wow. I may end up cutting out some of these little wait times because I don't want you to have to suffer with me waiting for this thing to go. So at some points, if you see the timer in the top right there where it's going 272, 273, those are seconds from the time that the bot clicked to start. If you see that skip, just know that I'm doing it for you. Or I've coughed or something and I'm trying to cut that out. Look at that. It just had one blank tile. I could probably make that more efficient. Let me tell you, I went for like weeks. I would go into the kitchen, the dining room, and I would just pace and talk to my wife about what I wanted to do or how could I change this thing to be more efficient. And I'm telling you, it just consumed my life for a period of a few weeks. And I would go in and rebuild the automation, rebuild the flow to be completely different from how it was before. And it would be more efficient than the time before. But then I would build some that were even less efficient than it was before. And I kept running into these situations where, there would be a blank and I'm like, how can I make it efficient to know whether or not it should recheck everything? And it's so hard to think that through. I'm going to keep letting this thing play. If you're watching this with me, thanks for being here. I don't expect you to hang around. It's fine. I understand if you need to skip forward. I will try to put time hacks, timestamps for the different chapters, and you could skip to the end of this if you'd like to. But I'm going to try to just go ahead and let this thing go. I'm curious whether or not it can succeed. And I'm especially curious to see if it succeeds before 999 seconds, because that's the max amount of time that the game, the Minesweeper game will actually show us. So it gets to 999 and then it just won't count up anymore. And my goal was just to see it solve in that amount of time, which based on how much it's solved already, I think that it's either going to fail before then or it's going to solve it before then. Okay, we are getting about close to half the time that this thing is allotted. Right? So if its max time is like 999. Okay, so I think right about now is when we are at halfway through. Wait, no, that's not right. It would be 500 seconds, not 450. Math is hard. Can you imagine if I struggled to just multiply 450 times 2? Like how hard it would be for me to do the math involved in this? That's why it took me weeks to figure this out. Okay, we got another blank space open up. Pretty awesome. I'm telling you, this thing would solve it so much faster depending on the scenario. Like if there aren't as many sections of blank tiles, this thing would solve it just exponentially faster. Exponentially means a lot, right? Oh my goodness. Look how close we're getting. Wow, so we've gotten up to 5. Have we seen any 6s? We have not seen any 6, 7, or 8s. No, we lost. Oh, keep playing. Let's say no. I just wanted to leave this screen on here. Okay, so the reason it failed, let's see, what's the reason it failed? Okay. This is still a success for us, though, because a person, while granted, I think I would know what to do, I did not build the flow to have complex rules. And so it ran out of rules to process. Remember I said it would loop through all the number tiles, which granted all of these have all been processed up here, right? So it's not actually looping up through all these anymore. but it was looping through these ones that are down here, and it didn't have any rules it could process. And so it just decided to click the top left tile that's new. So in this case, this was the highest up, right? So in this row right here is the highest row that had a new tile in it, and it clicked the far left new tile in that. So it did exactly what it was supposed to, and there's a little bit of random chance in whether or not it will be correct. But I think 522 seconds, it only had, 2.5 rows left to process. It probably would have finished in like, let's say 700 seconds, maybe a little more than that. And I'm pretty happy with it. So that was like an hour and a half of me explaining how I built this flow to solve Minesweeper in Power Automate Desktop. And then we just demoed the solving of the beginner, intermediate, and expert levels in this Minesweeper app. So that was probably, a good like 15 minutes or however long that was. But that was a lot of fun to build this. It took over my life for a while, but I am really happy with how it turned out. And I actually might come back and rebuild this thing after Microsoft changes a few actions, maybe gives us more actions, more flexibility, variable inputs, and that kind of thing. And then maybe I can come back and resolve this, and it might be even faster. That'll be pretty exciting to see if that happens. But for now, I'm going to leave this topic. If you'd like to see me solve this thing from step 1 to step, 999, let me know, and I might be able to make a video showing every single step. But fair warning, this was like an hour and a half for me just to explain what I did. Imagine how long it will take me to explain it and build it. So it'd probably be like a 4-hour video. I don't know if anybody has the time to watch that or cares. Let me know, and I'll see if I can make it happen if anybody is actually interested in that. So for now, I'll just leave you with this video. Thanks so much for watching, and I'll see you in the next video.